Good morning, everyone. This is Aslı Özyürek from the Netherlands, from Radboud University Donders Institute. I would like to thank, first of all, Burcu Ayşen for inviting me to this interesting conference and all the organizing committee, of course. I was really looking forward to being there and meeting all the cognitive scientists in Ankara, but unfortunately, we have to meet in a virtual environment. I have to say, I have to apologize that I couldn't record my face and hands for this presentation, even though I tried very hard, but I couldn't figure out how it works with Zoom. So you will have to hear me talk. So today I will talk to you about how we use and process language in embodied, situated, and multimodal contexts, and the cognitive and neural infrastructures of these processes. I will also tell you about how we do this in different languages, including Turkish, and I hope it's relevant to your work. So when we use language in face-to-face interactions, that used to be the case before the COVID-19 pandemic, we don't use only our vocal modality, but we use our hand gestures, facial expressions, eye gaze. We see the other person's lips moving. So vocal channel is always complemented with other bodily expressions. We can also, for example, point to things around us. However, after COVID-19, a lot of the vocal and the visual aspects of our communication are hindered. For example, we cannot see the lips anymore, or in these online platforms, you can't even see me anymore. Or you can see only a thumbnail of my face. So even though the research I will talk to you today pertains to pre-COVID times communication patterns, I still hope and I believe that they are also relevant to understanding the new ways of communicating. And in certain experiments, I will also talk about specific implications for the COVID-19 era communication. So I have to say that this multimodal approach to language use is not or has not been a traditional way of studying language. From the historical perspective, starting from Saussure, Chomsky, Hawkwood, Fodor, etc., the view of language has been quite limited because they have considered only some aspects of our communication as linguistic, so-called linguistic. For example, they have mostly considered spoken or written forms of communication as linguistic, and they have ignored the visible aspects such as the body, face, etc. They've also focused more on the arbitrary and the categorical structures, representations that are mostly in spoken languages, and they have ignored the iconic and indexical ones. For example, facial expressions or the way we move hands are sometimes very hard to think about them as categorical structures. Language is also viewed as a static entity or static structure rather than a dynamic, evolving, adaptive way of communicating. It's also mostly language is studied from one channel and not usually from multi-channels. And from the cognitive science viewpoint, it is considered to be a distinct modular system and does not necessarily interact with other aspects of our cognition, such as like other forms of intelligence or vision, perception, etc. But in my research, I try to advocate the point that we need to think of both sides of the communicative system to be able to understand our language faculty, how it's used in multiple contexts, adaptive and in a multimodal way. And also including not only spoken languages, but also if you want to include sign languages of deaf communities into this broad understanding. So in my research, I tried to develop an ecological and multimodal model of processing language and in a cross-linguistic way that would be valid not only for different types of spoken languages, but also for sign languages. So in this model, I presume that language producers prepare their messages with a certain communicative intent, and this communicative intent is expressed in all modalities that are used, for example, not only in speech, but also in gesture. And all these multimodal messages are then observed and interpreted in an integrated way by the listeners, and to be able to understand the communicative intent of the producer. So this, I also try to understand, of course, the cognitive and the neural infrastructure of how this works from both the producers and the listeners. And even though today I will talk about speech and gesture as different modalities, I think this model also is valid, can be transferred into sign languages that also use multiple modalities, not speech, not vocal modality, but the facial expressions, body, and the hands. So when people speak, they use different types of visible references that we call as gestures. These can be iconic gestures that bear certain resemblance to the objects, actions, and motions that they represent. So they are not as categorical, they are not arbitrary. However, they are also not just mimicking of things, what we perceive. For example, this motion gesture about cat hopping away is quite an abstraction of the movement of the cat. However, it's still iconic. We can also point to things around us, but we can also point to abstract spaces around our gesture space to refer to, for example, people or objects that we are talking about in a narrative context. Today I will be telling you mostly about iconic gestures and how they are integrated with speech during production and comprehension. So there are different views on the role of iconic gestures in language processing. According to some views on the left, gestures can be seen as direct representations of imagery. For example, how we open a jar and how we see a cat moving across the street. So gestures are generated from our embodied simulations or sensory motor experiences that we activate while we are speaking. So they are just mere reflections of this simulation as we speak. And they are not necessarily communicatively intended because they are just a byproduct of simulations. And they should then recruit mainly motor or visual areas of the brain. However, according to the language gesture interface hypothesis that I will try to give you evidence today, gestures are considered to interact with language production and comprehension processes. So it's not the idea that they don't reflect any simulation representation of imagery, but they do so in ways interacting with linguistic representations. They are communicatively intended and they recruit similar brain areas involved in language processing, such as the left temporal and the frontal areas. So then in this talk, first I will tell you about the production of the multimodal utterances and later about their So how can we show that, first of all, from the production viewpoint, iconic gestures interact with language production system? So one way to look at this is to see if iconic gestures of the same event differ across different languages that have different structures or different ways of encoding the same event. In order to test this, a long time ago, we developed a paradigm where we asked English speakers on the one hand versus Turkish and Japanese speakers to view the same events, and then we asked them to talk about it, and we looked at their gestures. So in this study, we particularly focus on one motion event, or we focused on many motion events, but one was particularly striking. So in this event, which was part of a Sylvester and Tweety cartoon, Sylvester swallows a bowling ball through on him by Tweety, and then he rolls across the street, rolling with this bowling ball. So in order to talk about both the manner of rolling and the path of going across the street, English speakers can express this with one verbal clause. So they have the manner, rolling, as the main verb, and they have the down the street, the prepositional phrase or the satellite to express the path. But if you look at it syntactically, both of these components of the event can be expressed in one verbal clause. Turkish and Japanese speakers, on the one hand, they have to use the path as expressed in the main verb, and they put the manner in a subordinate verb, but nevertheless they have to use two verbs to express manner and path. So we wanted to see if then English versus Turkish and Japanese speakers use different types of gestures. So if we think that one processing unit of information during speaking is a verbal clause, then we would expect Turkish and Japanese speakers to use separate gestures, one for manner, one for path. But for English speakers, we would expect English speakers to produce one gesture where both manner and path can be represented in one gesture. And actually, this is what we found. For now, I will show you an English speaker talking about this scene and gesturing.
He rolls down a street into a bowling alley.
So as you see here, she uses one verbal clause, manner and path. She also uses one gesture where both manner and path are expressed. However, for Japanese speakers, this is not the case. And similarly for the Turkish speaker. So these findings, which we replicated for different events and with different languages as well, they show that iconic gestures are not only shaped by what people see, unlike the gesture as the simple imagery hypothesis, they are shaped by what can be expressed by verbal units, or by the way that languages package information for purposes of speaking. So we also recently had some converging evidence from blind speakers. So even blind speakers who cannot see the events, or they have not seen other people gesturing, they also show similar patterns. So a while ago, Şeyda Özçalışkan and Susan Golden Meadow have asked English and Turkish blind speakers to experience some motion events haptically, and then they have asked them to talk. So they have also shown that when Turkish speakers talk about these motion events, they use mostly path gestures with path encoding, path included in the main verb, whereas English speakers, they are more likely to express both manner and path in one clause, and they use both manner and path gestures. So these results show that gestures are really linked to how events are expressed by the linguistic structures, and these findings are not just mere effects of culture or seeing how others gesture. And with Ezgi Momuş, Asfa Majid, and others, we are also testing similar claims from the perspective of auditory motion events. For example, when blind people hear motion events, then do they also show similar gesture representations? And the pilot results showing that this is the case. Okay, so as the next step, we wanted to see if speakers not only produce their gestures with language-specific patterns, but do they also prepare their messages for gesturing in similar ways that they do for language production. Previous research on spoken language production has shown that speakers of different languages look at events differently just before they are preparing their message for speaking, depending on their language. For example, Greek speakers are like Turkish. They encode path in the main verb, so they are more likely to look at the path before they speak compared to English speakers, who then mainly look at the manner, for example. So we also now wanted to see whether producing language-specific gestures, in our case path gestures, also guide visual attention of Turkish speakers to paths during message preparation. So we asked Turkish speakers to talk about another set of manner and path events and later describe them. And while they are doing this, we recorded their eye gaze. And this project has been conducted with Ercener and Önal from Özyeğin University while she was a postdoc in my lab. So what we found is that Turkish speakers show the patterns that we expected. The most common pattern they used was they used the path in the main verb, such as enter, and then they also used manner quite a bit, but as a subordinate verb. When they gestured, their gestures were mostly about path, not manner. And we think this is again due to the fact that that Turkish encodes path as a main verb. So as a next step, we wanted to see whether they also look more to path than manner before they start producing their expressions, and whether this tendency increases when they produce a gesture versus when they don't produce a gesture. So these were the regions of interest we looked at, whether they looked at more to the phone booth or to the movement of the agent. So these are the eye tracking results. So the above lines show the preference of looking at path and manner. So when we look at people's looks before they produce only spoken expressions, these are the blue lines. So they do have a preference for looking for path and manner. And this again resembles, for example, what was found for Greek speakers. But what's interesting here is that if people are going to produce a gesture together with their speech, so this effect increases, so they even look more to the path than manner when they gesture. So then this shows that again during not only in the overt behavior but during message preparation, then people plan their gestures together with their linguistic production, and that language specific gestures guides visual attention to events. So what about whether iconic gestures are communicatively intended, because the gesture as a mere imagery viewpoint does not assume this, so it needs to be shown whether gestures differ depending on who somebody is talking to. So to test this, we asked some Italian speakers to explain how to make coffee in the Italian style in different addressee conditions. In one condition, we asked them they were all talking to a camera, but they were asked to imagine different addressees, whether they imagined an adult addressee who already knows how to make coffee, or they were asked to imagine a 12-year-old around child who doesn't know how to make coffee. So we found that even though their speech was quite similar in both conditions, their gesture differed. So here now I will show you a part of the description where he says, when the water boils, the coffee goes up. When he's talking to an adult, it's the kind of gesture he makes. Okay, he just uses some kind of interactional but not iconic gesture. But when he speaks to a child, so here, as you see, he uses a very specific iconic gesture. So overall, we found that the more communicative intent was involved in the narration description. There were more iconic gestures. Also, their size and informativeness, their detail, the fact that they were used with both hands, increased, showing that iconic gestures are used for as they are needed for communicative purposes. So it's not just a matter of simulating the event components. Okay, so what about whether listeners also comprehend multimodal messages in an integrated way from speech and gesture in the same way that produce them in an integrated way? So to test this, we wanted to see whether seeing somebody's gesture influences their speech comprehension. So to do this, we gave participants first some kind of simple action events, such as somebody chopping some vegetables. And later they were given some speech and gesture events that depicted this action. So in 1/3 of the cases, the speech and gesture they saw after the action, they were matching each other. So somebody said cut and they did a cut gesture, as you can see here.
Chop.
Okay, chop. However, in another third of the cases, even though again they heard chop, they saw a slightly different gesture, which was still semantically related, but not matching the speech that they heard.
Chop.
Okay, so here we can see that the speech and gesture mismatch, but still they were somehow semantically related. So we called it a weakly mismatching gesture. And in the last set of conditions, our listeners, participants, again heard chop, but they saw a very different, not semantically related gesture.
Chop.
Okay, so the participant's task was to decide whether what they heard, because we didn't tell them about gestures, or what they heard, like chopping, matched the event that they have seen. So in all these cases, the answer should be yes, because CHOP really matches the action they've seen. But if seeing gesture influences their speech comprehension, then we would expect them to make more errors. The more mismatching the gesture is, then the more errors should increase. And actually, it's exactly what we found. Especially, it was really important that strongly mismatching gestures disrupted speech comprehension much more than weakly mismatching gestures, showing that the semantic information from gesture was really processed and that integrated with perception of the speech. So this is, I think, similar to McGurk effects that we see between lips and syllables match and mismatch. And I'm very happy to report to you that the results of this experiment was replicated with similar results in the Göksun lab by Demet Özer and Tilbe Göksun in Turkish, and that some individual variation was found in this process. So I'm really happy about the cross-linguistic replication of this. Okay, so what about the neural correlates of gesture comprehension? So if speech and gesture are also integrated during comprehension, so is it the case that listeners also use their brain areas that they involve in language comprehension also for gesture processing or understanding gestures? As I said, the other accounts of gesture processing, they don't necessarily, as us expect, some kind of semantic areas of brain or language specific areas to be activated. So to answer this question, actually we conducted a lot of experiments. So one of the first ones was to see whether gesture comprehension evokes similar electrophysiological markers such as M400, which is an index of semantic comprehension in a spoken language, to see whether gesture also evokes gesture speech mismatches also evokes M400 component. Now I will have to go 2 slides back. So we know from spoken language research is that M400 effect is sensitive to mismatch of the word that you hear or the possible semantic integration of the word you hear in relation to the previous context. For example, if you hear something like pizza was too hot to cry, so you get a higher M400 effect than when you hear the pizza was too hot to eat. So we wanted to see if gesture mismatches speech, you also see some similar increase in M400 effect. So we gave subjects the type of speech gesture mismatches that I mentioned you about. So if we tested or we recorded their brain signals in cases where they heard speech matching speech and gesture versus mismatching ones, for example, hearing twist but seeing a cup gesture, chop gesture. So here you can see that we find a very similar M400 effect, which is evoked after you hear the word and you see the gesture, so because they come together. So if speech and gesture are mismatching, as here, then you see a bigger M400 effect than you see a matching speech and gesture. And interestingly, the fact that people see both modalities does not necessarily increase this effect, decrease it, or make it come later. So it seems like there's not much difference in the way that gesture is comprehended, different than word is comprehended. So we also did our lab, or many other labs have done imaging experiments while people are scanned while they are watching speech gesture combinations, either in matching versus mismatching cases or speech only versus speech plus gesture, to see which areas of the brain are involved in processing iconic gestures. So the meta-analysis of all of these findings converge on the fact that mostly these effects are left brain dominant, even though we see some similar areas in the right brain as well. However, they are left brain dominant. And they do evoke mostly temporal areas, the posterior temporal areas, as well as left inferior frontal cortex, BA44, 45. So they do show a lot of similarities to how semantic information is processed from language. Okay, so all the previous examples of speech gesture comprehension I've shown you focused on mostly on the hands. Most of the time we have to block the lips, and so there was no other way but to integrate the information from gesture. And they also sometimes use these mismatch paradigms, which were not really ecologically valid because this is not how we see speech and gesture in real settings. And we know that, in real life, when people look at each other, they also see the lips as another visual articulator with communicative information in addition to hands. So maybe when lips are there, then gestures get less attention. We also know from some eye tracking studies is that for example, people mostly look at the face, but they don't look at the gesture. So we wanted to see the relative contribution of gesture to language comprehension, even when the lips are there. Lips are there to express phonological information, but not necessarily semantic information. But when we started our recent research on this, there was really nothing on to assess the relative contribution of both modalities. And of course, this is a very important topic. For example, when we think of situations such as noise, or when we are giving therapies to people with language impairment, speech impairment, and so on. So in order to study this, we also changed our paradigm from mismatch to studying speech in noise. Again, in the old times, I again use this example of people talking in a noisy bar or a restaurant, and how they kind of understand each other. So in this study, which was done by Linda Drivers as a PhD thesis, we asked whether listeners use information from gesture on top of visible speech, that's the lips, in disambiguating speech in noise. In order to do this, again, we use single words and single gestures, and we came up with 3 conditions. In the first condition, speech was there, but we blocked the information from the mouth. In the second condition, the lips were visible and the speech was heard. And in the third condition, on top of the 2 articulators, we also had the gestural information. So we expected that the more articulators that you have, the better you would be able to disambiguate the noisy speech that you hear. We also manipulated the speech in 3 ways. Either speech was clear, or moderately noisy, or severely noisy, so you could hear very little. So subject's task was to write down what they heard in seeing all these conditions. So in order to understand the benefit of lips versus the benefit of gesture in speech comprehension, then we calculated these enhancement effects based on the correct responses. Then to benefit of lips, we had to subtract middle condition from the first one, and for the gesture, the second condition from the third one. So this is an example of a noisy speech with all articulators. Okay. So I would love all of these experiments to be done in Turkish as well, not yet done. It's the first study of this kind, but all our examples are in Dutch. So what do we see here is that these are the results for severe degradation, and these are for moderate noise in speech. So in both of them, you can see that there is some lips enhancement compared to cases when lips is blocked. However, when you also show the gestures, so the correct responses increases. So there's more enhancement from when gesture is added when just lips is added. So some gestures contribute to disambiguation of speech and comprehension on top of the lips. And as we can see here, the lips enhancement is not as much as we had hoped or people have claimed, because we are in our experiment, we showed the whole body, but not just the lips as was being previously done. So another interesting thing is that people benefited both from the lips and from the gesture much more when the degradation of the speech was moderate than severe. If it's severe, then actually, especially for lips, the contribution of lips to speech understanding is really little, like 10% of the cases it made an effect. So then, first of all, these results show that people, even when the lips are there and that they can help speech disambiguation, people still pay attention to gestures, and then they use this information to integrate with speech. So this, I think, not only has implications for example, how we conduct speech therapies and talking to people who can't hear well or old people. I think it also has implications for the current regulations of COVID. As we know, we are more and more using masks. So a lot of people are worried that masks are covering the lips information. So a lot of people are designing new masks for where we can see the lips. But I think this will help, I think, a little bit. But the most problem with masks is that they also block the sound, not only, so they create noisy context. So if you look at our results, one solution when you're communicating with masks is actually to use gesture. Not only see the lips, but using gesture will be much more informative in many settings. So finally, we also wanted to see which brain areas are involved when gesture is used to disambiguate speech in noisy contexts. So based on our previous results, we expected that gestures would help understanding speech by making lexical access possible, because it recruits similar brain areas involved in language comprehension. So we want to see whether also in this noise context, gesture is evoking language-specific brain areas when it helps speech disambiguation. In order to do this, we conducted an imaging study, which gives us not only the brain areas involved in this, but also the time course of how disambiguation might occur. And in doing so, specifically, we looked at the modulations of the alpha brain signal, alpha waves. These are in general slow brain waves, which, however, decrease in alpha waves increases the task relevant brain areas. So by tracking where this decrease happens in alpha waves, we over time we wanted to see which brain areas are involved when gesture helps speech disambiguation. So here you can see how a person prepares their gesture, execute, for example, here a zipping gesture, and these are the brain areas that are involved. That shows the alpha going down. So what we see here that as soon as the gesture is more meaningful in the middle of the gesture production, and this is again when the speech is noisy, there's first a right SDS involvement, then followed by left brain activation, and after that it goes very much left brain dominant activations. We see the involvement of the motor cortex, which involves probably some simulation of the action so that it's understood better to help speech comprehension. And followed by temporal and frontal areas that are also involved in semantic comprehension in language, and also followed by the occipital cortex, which shows that people attention even more to the gesture characteristics when they are using it to disambiguate noise. So these results show that not only the brain areas, but also not only brain areas specific to language, but the ones that are broader, that are motor cortex and occipital areas can be also involved, also in line, kind of in line with previous accounts of gesture processing. Okay, so as a result of all this talk, I tried to give you evidence for this ecological and multimodal model of language processing, looking at different types of languages. So from the producer's viewpoint, I tried to show you that just speakers design their gestures integrated with linguistic encoding of information and with communicative intent. And as a result, listeners integrate this information from gestures with speech and using similar brain areas and neural correlates. And there's a lot of, so all of this shows some kind of cross-linguistic variability that we hope to cover more in the next years. And if people are more, would like to do more neuroimaging studies with gestures and Turkish, I'm very happy to collaborate. And I didn't mention here so much, but the Tilbe Göksun lab, also we are collaborating in another project. There's quite a bit of individual variation in the way that people integrate information from different modalities, sometimes based on aging, working memory limitations, and so on. So then I think I gave you enough evidence to show that we need to go beyond traditional approaches to language, and as you know, during processing of multimodal context, then people do take into account both types of, both aspects of communicative situations. So, of course, there are a lot of remaining questions and implications. For example, even though we know quite a bit from the listener's perspective, listener's brain, what does listener's brain do with the multimodal information? We don't know how producer's brain, which parts of the brain are involved in gesture production. And again, there are some studies going on in this with semantic dementia patients, aphasia patients, and so on. But to some extent, patient studies are hard to hard to do, but doesn't mean that we shouldn't do them. And there are many labs doing this with interesting results. And I would also really like to know whether, like production, whether the comparison of gestures are also language specific, for example, because we know that Turkish people gesture much more. And do they also integrate? Are they more likely to integrate gestures with speech, or are they look at gestures much more? And I think, again, with our collaborative studies with Demet Özer and Tilbe Göksun, we have some maybe preliminary results about this. And further, I think our results have implications for how to deal with speech and language impairment therapies, as well as language teaching, language acquisition, and of course, the visual and auditory input degradation during living with COVID-19. And I would like to thank everyone in my lab and the previous contributors to my lab for making all these studies possible over the years. And I really apologize for the kind of low quality of this presentation and not being able to show my video. I'm looking forward to your questions, of course.